A very simple question based on the basic concepts of quadrilaterals. Okay, so let's first of all draw a figure for this. Okay, now the ratio of all the possible pairs of adjacent interior angles of a quadrilateral are given. So I'll draw a random quadrilateral and we'll call this as A, B, C, and D. So angle A, angle B, angle C, angle D, in this order I'll be going, because the question is talking about the order as well. So the first ratio, I'll assume it as the ratio of A and B. So A is to B is given as 1 is to 2. B is to C, the order. Okay, you'll have to maintain the order, 4 is to 7. Now since I have B common here, so I'll multiply the first ratio by 2. I can write it as 2 is to 4. So now 2 is to 4 is A is to B, and then B is to C is 4 is to 7. It will continue. So C is to D, in the question it is given as 7 is to 5, and D is to A is given as 5 is to 2. So now combining all the four ratios, you can say that the ratio of A, B, C, and D, the ratio of angles A, B, C, and D is 2 is to 4 is to 7 is to 5. The sum of the angles is 360 degrees. So from there you can find out the value of each of these angles. So 2x, 4x, 7x, and 5x. If I'll assume these angles, so I can say that 18x is equal to 360. So the value of x comes out to be 20 degrees. Substituting, the angles in the order will be 2 into 20, that is 40. 4 into 20, that is 80. I'm writing these values in the figure. 7 into 20, which is 140, and 5 into 20, that is 100. Okay. Now, if this quadrilateral will be a trapezium, then in a trapezium, the sum of the angles, sum of these two angles and sum of these two angles should be 180 degrees. So here the sum of adjacent angles in no case is 180. So it cannot be trapezium. In a parallelogram, opposite angles are equal. No, it is not. So either it will be a random quadrilateral or a cyclic quadrilateral. Now what is a cyclic quadrilateral? In a cyclic quadrilateral, the sum of opposite angles is 180. This is the property of angles, but cyclic quadrilateral is a quadrilateral such that all the four vertices of the quadrilateral are lying on the circle. Okay, and the property is the sum of opposite angles, both the pairs of opposite angles should be equal to 180. So in this 40 and 140, the sum is 180. Also 180, the sum is 180. So I can say that this quadrilateral is a cyclic quadrilateral. Option A is the correct answer.